So we want to see how we can add and subtract radicals, and one of the steps we learned last time was to first have to simplify the radical. So if we want to add and subtract radicals, first step, simplify all radicals. The second step would be to combine like terms and use the distributive property. And we'll see what that means, that once we simplify the radicals, we can combine the ones with the same roots and use the distributive property to add or subtract them. So let's take a few examples. So here we're asked to add 4 root 5 plus 3 root 5. So first of all, we see if we can simplify the radical. Underneath these roots, we have 5, and we can't simplify any further. So now we're asked to, the next step is to combine like terms. Well, they're like terms in terms of the root, and that's what we mean, combine the like roots. So the root here, root 5, is the same as this root 5. And so we can use what we call the distributive property, which we've used before, to add these two. In other words, I can actually factor out a root 5 because it's common. And what we're left with would be 4 plus 3. And 4 plus 3 is 7. And so this would give me root 5 times 7. However, normally we write the number, the root after the number, so more properly this would be 7 root 5. So this is the technique we're going to use when we combine, when we add these like terms, is we're simply going to add the numbers. 4 plus 3 gives me 7, as long as the roots are the same. We'll do a few more examples. Okay, so part A, we're asked to add 3 square root of 10 plus square root of 10. Now the roots are the same, which is the square root of 10, and they can't be simplified any further. So we simply just add 3 plus, what number sits in front of this root? 1. It's an unwritten 1. So 3 plus 1 gives me 4. In other words, we had 3 of these root 10s, and I added to another root 10, we're going to have 4 root 10. 4 times the square root of 10. Next example, root 3 plus root 3, that means we're going to have 2 of them now, because we have 1 root 3 plus another root 3 gives me 2 root 3s. Part C, root 50 minus root 8. Now, these we have to simplify. First, we always have to look to see if we can simplify these radicals. Well, 50 is 25 times 2. So I could rewrite this as the square root of 25 times 2. And 8 is actually 4 times 2. So 8 is the square root of 4 times 2. And now we take out the perfect squares. In other words, we square root the perfect squares. The square root of 25 is 5. So we'll have 5 times the square root of 2, what's left over, minus the square root of 4 is 2. 2 times the square root of 2. Now we have like radicals, root 2 here and root 2 here. So we simply do the subtraction. 5, the number in front here, 5 minus the number in front here, 2. 5 minus 2 gives me 3 of these root 2's. And so my final answer here would be 3 root 2. Okay, in this problem we have some variables and we're asked to add or subtract. We have 2 times the square root of x squared minus the square root of 25 times x to the 5th, all under the square root, plus the square root of x to the 5th. So we have to follow the procedure. First we simplify if we can under each radical. Well, the first radical is simplified as much as we can go, and actually we can square root of x squared. The square root of x squared is just x, so we can actually have here as 2x. Immediately we can do that. Minus, now, 25, I know we can square root 25, but x to the 5th power, we have to break that down. Remember, we're square rooting, so we want an even power up here. So we can rewrite this as the square root of 25, and the next power down is x to the 4th, and then we'll have an x next to it, because x to the 4th times x gives me that x to the 5th. Similarly, with this x to the 5th, we can break that down as x to the 4th times x. So now we can simplify these two radicals. So we have 2x minus the square root of 25 is 5. And the square root of x to the 4th is x squared. We divide by 2. So those two are gone. And we're left with the square root of x. plus, here we're going to have x squared as well. Square root of x to the 4 is x squared. And we're left with square root of x. So now we can combine like terms if there are any. And here we see that these are actually this like terms here. We have an x squared, both of them have x squared, and both of them have square root of x. So we have 5 of these, a negative 5, and then we're going to add 1 of these. So negative 5 plus 1 will give me negative 4. So we'll have 2x minus 4 times x squared root x. And that's as far as we go with this expression. But that's the simplified version of this expression up here.